This is Honors Pre-Calculus Final Exam Review, problem number 52. And we have a nice long word problem. When sitting atop of a tree and looking down at his pal Joey, the angle of depression of Mac's line of sight is 37 degrees 54 minutes. And we want to right away focus on this phrase, angle of depression. And as soon as we see angle of depression, we want to think that angle of depression and angle of elevation, which by the way appears in the next problem, are both measured from horizontal. So if we think about angle of depression and angle of elevation, if I look horizontally and I look down at something, then the angle of depression is right here. And if I'm standing at the ground and looking up at something, then I look to the horizon and look up, and that's my angle of elevation. So I want to keep those two things in mind as soon as I see angle of depression, angle of elevation. So here's angle of depression, and we give a certain angle. Joey is known to be standing 23 feet from the base of the tree. How tall is the tree? All right, so an important thing with a problem like this is we need to draw the picture of what's going on. So somebody's sitting on top of a tree. All right, so we'll just draw a nice tree here. There's a tree. This tree has some nice purple leaves on it. And sitting on top is Mac. So here's Mac sitting up here. All right. Now, he's looking down at his pal, Joey. So here's Joey down here. Joey, looking down at Joey. I'm Joey. And it says the angle of depression is 37 degrees 54 minutes. So the angle of depression, and I'm going to measure that angle of depression just from the top of the tree because I don't want to confuse the issue by how tall Mac is. So I'll just draw that angle of depression like this. And then I'll label it 37 degrees 54 minutes. 37 degrees 54 minutes. Now, what else do we have? We have Joey is known to be standing 23 feet from the base of the tree. And we have to watch out for words like base, because are we measuring 23 feet from Joey, from Mac to Joey? No, because Mac's not at the base of the tree. We're measuring 23 feet from the base of the tree, which is down here, and we're going to say this is 23 feet. So that's 23 feet. And the question is, how tall is the tree? So the information we're looking for is this height of the tree. All right. So one thing we want to do for in these problems is look for the triangle and also ask ourselves, is it a right triangle? So when I look at this problem, first of all, I see the triangle right here. There's a nice triangle. I made it a little bit crooked, but not too bad. And then the next question I want to say is it a right triangle? Well, presumably the tree is straight. The problem didn't say that, but trees normally grow up vertically, so I think we can call this a right angle down here. Now we like that it's a right triangle because now we can use our trigonometric ratios, SOHCAHTOA, sine is opposite over hypotenuse, etc. And we can also use Pythagoras' theorem. So let's look at this and now see what we want to do. So the height is what we're trying to find. That's our x. And we'd like to start saying, maybe it's opposite over adjacent or something. But I have this problem that the angle here, in order to say what is even opposite and what is adjacent, I need to know what angle I'm referring to. And this problem with this angle is it's not inside the triangle. So I have two options. I can subtract from 90 and find this angle, which is in the triangle, or probably much easier, I can take advantage of the fact that the two horizontal lines are parallel. So since these horizontal lines are parallel and they're cut by a transversal, that means that these two angles are alternating interior angles. So since this is 37 degrees 54 minutes, this must also be 37 degrees 54 minutes. And then you find a relationship, by the way, between angle of depression and angle of elevation. Because if the angle of depression from Mac to Joey is 37 degrees 54 minutes, then the angle of elevation from Joey to Mac has to be that same angle. So now we have an angle that's inside the triangle, and we're allowed to use that to find what our various sides are in relationship to that angle. So this angle, the x is opposite to that, and the 23 feet is adjacent. And our hypotenuse, of course, is across from the right angle. So now that I've labeled opposite, adjacent, and hypotenuse, I can say, well, which of these two are involved in the problem? The adjacent is the given, and the opposite is what I'm trying to find. So I need a trigonometric ratio that has opposite and adjacent in it. That, of course, would be tangent, because I have that memorized, because that's not going to be given to you on the exam. We need to know that tangent is opposite over adjacent. And I usually just start by writing that so I don't get confused as I'm going along. Now I can say this is tangent of 37 degrees 54 minutes. And the 54 minutes, the fact that it's in degrees, minutes, and seconds, I'm not even going to worry about that yet. I'll worry about that when I start doing the calculation. The opposite is x, and the adjacent is 23. So now I just need to solve this equation by multiplying by 23 on both sides. So I have 23 tan 37 degrees 54 minutes equals x. Now I can just do this on my calculator. Now what you want to do with the 54 minutes, we can think about that now. We can convert this to a decimal degrees by doing 37 plus 54 divided by 60. But I'm not going to do that as a separate step. Instead, I'm going to do that calculation right in my problem. So I have 23 tangent of 37 degrees 54 minutes. So I'm going to go 23. And I've already checked to make sure I'm in degrees. This problem is in degrees. And the various problems on this exam, some of them will be degrees, some of them will be radians. So we always have to be paying attention what mode we're in. This one's degrees. I already checked my calculator is in degrees. So now I'm going to do the problem 23 times tangent of 37. And so what I'll do is I'll do this plus 54 over 60. I'll just put that right in there in parentheses, plus 54 divided by 60. And then I'll close that parentheses. I'll hit enter, and the tree is 18 feet tall. And that's all there is to that. So I can say here, x equals, I could put 17.91 if I wanted, but I was only given this as 23 feet, one decimal place, two significant figures. The problem does not say where to round. Oh, actually, I'm wrong about that. The problem does say to round to the nearest foot. So regardless of what I think would be the good place to round to, I'm going to do what the problem says, which is to round to the nearest foot. So I'm going to say x equals 18, and just to be really clear, I'll say the tree is 18 feet tall. And that is number 52.